Hello. Here is the examples from the sections F.1 and F.2 about absolute value. First, a quick reminder about uh, watching these example videos. These are always going to go a little bit faster than a regular lecture in class does, so it's important to pause it and rewind as much as necessary. This is important. If you just try to sit and watch it and write it down as fast as you can, you're probably going to miss things. So pause it and rewind when there's something you don't understand, something you need to see again, and mark spots that if you watch something twice, 3 times, and you still don't understand it, then ask a question about it later and put a little question mark or some kind of symbol there, whatever you like, to remember that there's something there you don't understand. And then ask for help in the online office hours or in a discussion or something like that. Or in the CAS, which apparently the CAS is still open during the coronavirus situation, at least for now, as of March 12th. We'll see how that goes in the future. So, all right. So, absolute value. If you were in class this morning, you already saw the beginning of this. I'll put it here again as a review because a few people missed that. And if you want to skip ahead a little bit, that's okay. So, first of all, the absolute value of x, which we write with these vertical bar things, is the distance from 0 to x on the number line. So if this is a number line here, and 0 is right here, and you go out however many units it is to x, this distance is the absolute value of x. And if x is, I think I just realized that's getting cut off there. How can I make this get? Oh, there we go, a little higher. Okay. If x is a positive number, then you just get the absolute value of x is going to be just a positive number. But if x is out here, like you have a negative number for x, something like, I don't know, -4 or something like that, then this distance, the absolute value of x, is still a positive number. So maybe that's the way you originally learned absolute value, is just that it's always a positive number, and that's true here too. All right, so the absolute value of -3, that just means, whoops. If here is 0 on a number line, we're going to get the distance from 0 to -3. -4, -5, 1, 2, 3 over here. So this distance is the absolute value of -3, and that is 3 units, because -3 is 3 units away from 0 on a number line. Same thing with 3, the absolute value of 3 here. So this distance over here is 3, because the distance from 0 to 3 is 3. And so it's the same whether it's -3 or +3. All right, how about the absolute value of 20 minus 27? Well, to do this, you want to treat the absolute value bars as like parentheses, and do whatever operation is inside of the parentheses first. So in this case, that means 20 minus 27 is -27. Wait, what? -7, there we go. And the absolute value of -7, that's just the distance on a number line from 0 to -7, is just 7. And 27 minus 20 is 7. So that's still inside the absolute value bars. But then the absolute value of 7 is the distance from 0 to 7 on a number line, is 7. Okay, so you notice both of these give you the same thing, whether you do 20 minus 27 or 27 minus 20. So, and in each case, what you get is the distance between 20 and 27 on a number line. So if you have like 0 over here, and 5, 10, 15, 20, 25, 30. So 20 is right here, and 27, it looks more like 28. 27 is about here. 25 in there. Then the distance between 20 and 27 is 7. So that's whether you do it as the absolute value of 27 minus 20 or 20 minus 27. You get the same thing, and that's what this is here. This was what this says. In general, the distance between A and B on a number line is the absolute value of A minus B. So it looks like this. If here's A and here's B, that distance is the absolute value of A minus B. You could also do it as the absolute value of B minus A, because it works the same way. The distance from A to B is the same as the distance from B to A. This is different from when you talk about slope, like when you do like the delta y over delta x, and you do y2 minus y1 to get the change in y, and x2 minus x1 to get the change in x. These two things, the top and bottom of this fraction, also represent a distance on the y-axis or a distance on the x-axis, but without the absolute value, each of these things could be negative. So that's what we call an example of directed distance. Okay, so all right, let's look at these examples. We're going to use this fact that the absolute value of A minus B is the distance between A and B on a number line to look at some English sentences and translate the English sentence into an absolute value equation, an inequality. Or if we have a math sentence using algebra symbols, to translate that back into English. And either way, let's shade the solution on a number line. By the way, with this stuff, if it takes you a little longer to read this and really understand it, especially with these videos, I'm just going to kind of keep going through it. You might need to pause it and really read the example, because I'm just going to get right into it. So, and I also just noticed that the window that we're recording on is missing some of the stuff. Okay. I think you can see the edge there. Yeah. Okay, so let's look at this. The distance from 10 to x is 3. So first of all, the distance from 10 to x, we can write that using absolute value, using this fact. The distance from 10 to x we can write as the absolute value of 10 minus x, or x minus 10. It doesn't matter which way you do it. And let's see, the is going to be equals, and 3 is just 3. Okay, so the distance from 10 to x is 3, is what this is saying. So if you want to write the solution of this, the solution set, in other words, the values of x that make this work, well, it's a little tricky to look at it using the symbols if you don't know how to deal with it. But let's just think about what x's make this true. We want to make the distance from 10 to x be equal to 3. So let's look at a number line here. Let's start with 10 right here. And we're going to go 11, 12, 13. That is a distance of 3. So this right here could be your x. That's a distance of 3 from 10. Or you could go back the other way. You could do 10 minus 3 to get to this point right here, which is 7. So that could be x, or that could be x, and that describes that sentence. So that's the solution set, those two numbers. All right, now let's look at this. When we say x is within 5 units of 40, okay, so what is this saying about distance? I'm going to try to rephrase this. It's saying the distance between x and 40 is less than, or maybe equal to, it's not really clear what within means. Like, is 35 within 5 units of 40? I don't know. I'm going to say less than or equal to 5. So that's saying the same thing as this. You could go from 40 to the left as much as 5 units to the left or less, or you could go 40 plus 5 or less than 5 units. So let's rephrase this. When we say the distance between x and 40, that's, you can write that as x minus 40 in absolute value or 40 minus x, doesn't matter. That is less than or equal to 5. And 5 is 5. There. Okay, so what does this look like on a number line? Well, we're going to have 40 over here, and we can go 5 to the right up to 45, or 5 to the left down to 35. But that's as far as you can go. You can also go less than that distance. So including those, and x could be anywhere in here. All right, so the solution set, the way you would write this using inequality notation, like this here, or sorry, this isn't inequality, that's an equation, but using an inequality, what we're saying here is that x is greater or equal to 35, and x also has to be less than 45. So it includes 45, does not include 46. 46 is not within 5 units of 40. Does not include 34, that's too far. It doesn't include 45.1 or anything like that. So this is the solution written as an inequality. Okay, so let's look at a couple more. Let's see, the absolute value of 12 minus x is greater than or equal to 5. All right, so this time we're given the algebra notation, and you want to write that as a sentence in English. So what does that look like? Well, let's see. 12 minus x, that is the distance from 12 to x, or you can say between 12 and x, it's the same thing, is at least, is what the greater than is saying, this distance is bigger than or equal to 0.5. All right, so what can we do with this? Well, once you see this written as an English sentence, we could describe what x makes that work. So we're saying the distance from 12 to x is at least 0.5. So let's look at where 12 is here. Let's say that's 12, 12.5, and 13, 14 over here. And then let's have 11.5 and 11 over here. So we want to get the distance from 12 to x to be at least 0.5. Where would that be? Well, it could be at 11.5. That would work. or anything to the left of here. All of this stuff out here is all farther away from 12 than 0.5. The distance is more than 0.5. Or here's 12.5 right here. And you could go all the way out here. All right, so all of those things that I've shaded there could be x. X could be over here, or x could be over here. To write that as an inequality, we would write x is less than or equal to 11.5, or x is greater than or equal to 12.5. And there's a difference between saying or here and. So when I say or, the reason there's an or is that one of these things could be true, but they don't have to be true to make the whole thing true. Meaning, for example, if you have x is, I don't know, 10, something down here. If x is 10, then this part is true. 10 is less than or equal to 11.5, but this part is not true. 10 is not greater or equal to 12.5, but that's okay. You don't have to make both of them true. In this case up here, in order for x to be in this set we're talking about here, both must be true. So you can't just have anything greater than 35, for example. Like 46, for example. 46 is greater than 35, so it would make the first part true, but 46 is not less than 45, so you can't count the 46. So this is why both of these things have to be true. Here, it's at least one of these must be true. That's what the or means. Okay, let's keep going. We got some different examples here. So we got another one we're going to try to translate into English. This one is saying the distance from x to 3 is less than -2. So what does that mean? Well, like the absolute value is always a positive thing. Just because when you talk about distance in everyday life, you never have a negative distance. Like the closest you can be to something is like 0 meters away from that thing if you're in the same spot. Or you could be 2 meters away. If you're like north of a spot, you could be, if this is a spot, you could go north 2 meters, or you could go south 2 meters, or you could go, which is east 2 meters, or you could go west 2 meters. And all of these other spots are 2 meters away. What does it mean to be -2 meters away from something, or -3? In this case, the distance has to be less than -2. So the distance would have to be -3 or -4 meters. That doesn't mean anything. So it's kind of nonsense when you write it as a sentence like this. But when you think about it in math terminology, like the thing about absolute value is it's always positive. No matter what x is, no matter what is inside of the absolute value, the absolute value is always a positive thing. Or maybe it's 0. So it doesn't matter what x is. It's always positive. Or maybe 0. This has no solution. There's no value of x you could plug in that will make this thing that's positive less than -2. So that's an important thing. When you're looking at absolute value stuff, first, before you try to do any math with it, take a step back. Look at, do you have the absolute value is compared to a negative number like we have with these two examples? If you do, regular methods aren't really going to make sense. So, like, thinking of it as distance doesn't necessarily make sense. Other stuff we do isn't really going to make sense. And you're just going to have to use what you know about absolute value, that it's always positive, to just answer the question. So with this one, this is the same idea. If I was going to write that out in English, it would basically be the same as this. It's just that this time, the distance from x to 3 is greater than negative 2. And like we said, the distance is always greater than 0, or maybe equal to 0. But no matter what x is, it's always greater than negative 2. So the solution for this is x could be any real number. Okay, now let's go on to the harder stuff here. So what if things, like these examples are all simple. If you ever have something where it's just the absolute value of a number minus x on one side, that you can just translate it into a sentence about distance this way. But a lot of the time, things aren't so simple. Like, what if you had instead of, like over here, what if instead of the absolute value of 12 minus x, what if this was 12 minus 2x? Then you could say the distance from 12 to 2x is at least 0.5, but it's tricky to see what that looks like maybe, like what actual x makes that work. So we're going to need two approaches to this. There's by graphing, which is where you graph two equations. You graph y equals the left side and y equals the right side, and figure out what values of x make the equation or inequality true. You don't have to memorize anything, but you need to know what to look for on the graph. This is my favorite way because solving things by graphing is a very powerful thing that you can use for solving all kinds of other things. There's also method B here, which is memorizing all of the following algebra rules and correctly applying them. So I think it's better to do it with a graph. Let's go over these algebra rules really quick. So let's see. If we have a as an expression with a variable in it, like a is something like, let's look at example 3 to start this off. In this case, the a is the 7 minus 2x. That's what's inside the absolute value. And what we have is that is greater than 4. The absolute value of a is greater than 4. So if we're going to use this algebra rule here, what this is saying is that that's equivalent to a is less than negative k, or k is less than a. So why does this work? Well, remember that the absolute value of a is the distance from a to 0 on the number line. That was our original definition of absolute value. If you don't have like x minus something in there, if it's just the absolute value of one number, it's the distance from a to 0 on a number line. So if we're saying the distance from a to 0 is greater than k, well, there's two things that could happen. This one would look like, if 0 is here and negative k is over here, then where could a be? A could be over on this side out here, or a could be beyond k on the positive side. Might be over that way, might be over this way. All of that is where a could be, because what this is saying, the distance from a to 0 is greater than k, so we could go there either way. And same idea with this one. If this one is saying the distance from A to 0 on a number line is less than k, here's a number line, here's 0, here's k, or negative k. And by the way, this only works if k is positive, all of these pictures. Then we're saying that k must be in here. The distance from, A must be in this range. The distance from A to 0 is less than k. And this first one here, I'm going kind of backwards here, this is saying that the distance from A to 0 on a number line is equal to k. So I'm going to write this right here so we can line it up. Whoops. We got 0, k, negative k. If the distance from 0 to k is equal to k, then k could be here, or sorry, A could be here, or A could be here. And then if k is negative, if you're saying the absolute value of A is compared to a negative thing, well, remember, the left side of this, no matter what, is always greater or equal to 0. So this is saying this thing that's always positive is equal to a negative number. This one's saying this thing that's always positive, the absolute value of A, is less than a negative number. That's impossible. So absolute value can't be negative. It can't be less than negative, which means even more negative. So either way, this has no solution. Now, if you have the absolute value of A is greater than a negative number, that's always true. No matter what your variable x is or whatever A is, the absolute value of it is always greater than any negative number, and the solution is all real numbers. So those are the special cases there. All right, so let's look at this example. This one is saying that the distance from 7 minus 2x to 0 is greater than 4. So we're talking about this third situation here. So let's use the algebra rules to do that. And then we'll do it by graphing and see how much easier that is. So the algebra rules say this is going to be 7 minus 2x is less than negative 4, or 7 minus 2x is greater than positive 4. All right, so let's isolate x in each case. We're going to do the same thing to both sides here. Subtract 7 from both sides, so you get negative 2x is less than negative 11. Divide both sides by negative 2. You'll get x is, remember you got to switch the sign here because you divided by a negative number. So this gives you x is greater than 5.5, which is what negative 11 over negative 2 comes out to be. So x is greater than 5.5. How about this one? If you subtract 7 from both sides, do the same thing. You'll get negative 2x is greater than negative 3. Divide everything by negative 2. Dividing by a negative means we got to change the order here. And that will give you x is less than 1.5. So this is saying x is greater than 5.5 or x is less than 1.5. Let's draw a graph of that. 0, 1, 2, 3, 4, 5. I think I need to stretch this out a little bit. 6, 7. Okay, so here's 5. Here's 1. Here is 1.5. And here is 5.5, halfway between 5 and 6. We want to include all the stuff greater than 5.5 but not equal to 5.5 is what the little open circle represents, and everything less than 1.5 also works. So either of these two things could be true for x, and that would work. Okay, so this is a lot of rules to remember. I guarantee, I mean, you might understand why the rules work and be able to come up with the rules again if you have to know how to deal with this. Um, or you might not. And a more useful thing is to know how to do this by graphing. So I'm going to open my graphing calculator app here. Do, 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 do. Okay. So we're going to go to y equals here. So I press y equals to get to the graphing area. Make this, whoops, not that big. Okay, so what we want to do is graph y equals the left side and y equals the right side. So the left side is the 7 minus 2x. So here we go. We're going to do the absolute value. Here's how to get to absolute value. Press the math button, which I know is kind of silly because aren't the rest of the buttons on the calculator math buttons? But anyways, one is called math, and you go over to num, which is also funny because you have all these other number buttons, but whatever. What we want is abs. Abs here is short for absolute value. Absolute. So that gives you absolute value bars, and you can do 7 minus 2x. So that is the left side of this, and the other side is just going to be y equals 4. So what we do when we graph this is we're going to see what are the values of x that make the absolute value of 7 minus 2x greater than 4. That will be what makes these y coordinates greater than the y coordinates that are 4. Let's look at the graph. So you might have a weird window. Remember, you can always do zoom to go to maybe number 6 for z standard is a good one. You can get a rough estimate just by pressing the trace button and tracing around. So it looks like if x is negative 1.48, y will be 4.02. This is on the graph of the absolute value one. So yeah, x equals 1.489 is a solution. That's right over here, just a little bit less than 1.5. Or if we go to the right just a little bit, x equals like 1.7 gives you y equals 3.59. And 3.59 is not greater than 4, so that means x equals 1.7 is not a solution. So anyways, looking at this, the part of the graph that we want to look at to get solutions is always going to be, put this over here where I have some room. The part of the graph that gives you solutions is the part where the y coordinate of this one is greater than 4. So because here's where these y coordinates here of all these points are all greater than 4. Maybe I should label on the y-axis. All these y coordinates are greater than 4. So what are the values of x that get you that? So what you got to do is figure out where does this cross. Because where does it cross? About here. It's about 1.5. And here it is at about 5.5. And so that's going to be where they intersect. So the solution set, the thing we're shading is values of x, right? Because that's the original goal when you're solving this thing is finding what values of x make that true. So all of these values of x out here also work. And the question you might be asking is, how do you know this is at x equals 1.5? How do you know it's not 1.51 or 1.6 or something like that? Well, what you got to do is use the calc thing over here. And we're going to go down to, so I press second trace to get to the calculate menu. We're going to calculate the intersection. So it asks for the first curve. When you only have 2 curves, it doesn't matter. Just press enter. For the second curve, press enter. When it asks for a guess, press enter, and you can see the intersection point is 1.54. And you can do the same thing over here to press second calc, number 5 for intersect. For the first curve, press enter. For the second curve, press enter. And if you want to get this point over here, you got to move the guess closer to that point. And hopefully it will give you exactly 5.5 when you press enter. So yeah, so that tells you that it's more precisely 5.5, which is the same thing we got doing it with algebra. All right, let's do one more of these. And I know this seems like a little tricky. You got to memorize how do you do all these buttons. Well, when you go into the real world, you're always going to have a phone in your pocket, and you can go on desmos.com to do this. So, or Wolfram Alpha, or other websites where you can graph stuff, and it'll be pretty easy. You got to know how to do this for math tests, basically. Okay, so let's look at this. Let's solve this one. First, let's do this one by graphing first. This will be a little bit easier by graphing, because you're going to see how quickly it can go once you know how to do it. And graphing is also more powerful for doing all kinds of other things. All right, so this time we're going to graph y equals 2 minus the absolute value of d minus 3 over 7. But we're going to call this x minus 3 because that's what calculator calls variables. So 2 minus x minus 3, all that divided by 7 is how you write that fraction. That is the left side of this. The right side is y equals 5. So when we graph it, okay, it looks like if you trace here, this one, the one that's like kind of going up and going down, that's 2 minus this absolute value. And it looks like all of the values of that, like all of 2 minus absolute value of x minus 3 over 7 is always less than 5. Like the y coordinates here, we have a y coordinate of 1.57, a y coordinate of 1.9. It looks like about 1.99 is the maximum. Maybe it's actually y equals 2 if you were to get more precise. No matter what, all these y coordinates are not greater than 5. So from the graph, you can see that this has no solution. Let's work it out the long way using the algebra rules. So to do this with the algebra rules, what we're going to have to do is, first of all, in order to use these rules, you need to have just the absolute value on one side by itself. You don't have that right here. There's like a 2 minus the absolute value. There's like a divided by 7. You got to deal with all that stuff. So to get just the absolute value, so you have something that looks like one of these, I'm going to subtract 2 from both sides. That will leave you with negative absolute value of d minus 3 sevenths is greater or equal to 3. I don't want to have the 7 here, and I don't want this to be negative either. So I'm going to cancel all that out by multiplying by negative 7 on both sides. So a negative thing times a negative thing cancels out to give you a positive, right? So this is going to give you, and also the 7 divided by 7 will also cancel out. So that will just give you the absolute value of d minus 3. Oh, but wait, I multiplied both sides by a negative number. We got to change the direction of the inequality. That needs to be less than or equal to negative 21. All right, and let's look at this. All right, if we got a negative number over here, well, The negative 21 is obviously negative. The absolute value of d minus 3 is always positive or 0, of course. So what does that tell you about this? Can this positive thing be less than or equal to negative 21? This is a case of the second one here. This has no solution. Okay, and again, from the graph, it's good to know what to look for here. Like, if we're trying to make this greater or equal to 5, we want to find the points where the y-coordinate is up here, where it's greater or equal to 5. If all these y-coordinates are below 5, that's no good. Those are not solutions. I mean, those values of x, in other words, are not solutions of this. Okay. All right, time for some exercises. Remember, if you can always go back in the video to see exactly what I was doing with the calculator, if you need to see what buttons to press, etc. And I'll post a video about the exercises a little bit later.